All right, here we go. So this is homework number 4, question number 4, part B. The directions say differentiate each of the following functions using derivative rules. You do not need to simplify your answer, but you do need to show sufficient justification. Okay, so looking at this function here, it's this function is the product of two polynomials. Here's one polynomial and here's a second polynomial, and they're being multiplied together. So there's two different ways you can do this. The first way is you can multiply these two polynomials to get one long polynomial and then use power rule throughout that one long polynomial to find the derivative. Or you can use product rule, like as was shown in a previous video. You can use product rule on this polynomial. On these two polynomials, since they're being multiplied together, you use product rule on these two polynomials. Okay, so we're going to do both methods. The first method, the first thing you do is method 1 of 2. Step 1 is multiply the two polynomials together to get one long polynomial. This step is something that was done in Algebra 2, so this shouldn't be new, and if it's challenging, it's okay. We're going to review it right now. Then once you have that one long polynomial, step 2 comes into play. Use the power rule on that one long polynomial to find the derivatives, also known as f prime of x, and we're going to do that right now. Okay. Step 1. So we're going to distribute this x all to each of these terms. Then we're going to distribute, and then we're going to put a plus sign. Then we're going to distribute this 5 to each of these terms. That's how you multiply these two polynomials together. Okay, remember, if you're multiplying two things that have the same base, you add their exponents. This is an invisible 1 here, x to the first power times x squared is going to give us x to the third power. Now I'm going to distribute this x over here to the 2x, multiplied by 2x. So it's going to be 2 positive 2x squared. Why is it x squared? Because this is x to the first and this is x to the first, and they have the same base. So the x to the 1 here plus the x to the 1 here gives you x to the 2. When they have the same base and you're multiplying them, you add the exponent. All right. Now we're going to distribute this x to this 3. We're going to multiply x times 3. Positive x times positive 3 gives you a positive 3x. All right. Now we're going to move over to this 5. We have a positive 5, and we're going to distribute it to each of these 3 terms. Positive 5 times x squared is positive 5x squared. Positive 5 times 2x is positive 10x. Positive 5 times 3 is positive 15. All right, so that's our one long polynomial. All right, now we're going to go to step 2. Use the power rule to find the derivatives. And if we need a quick review on power rule, step 2, power rule says that if you have a function, let's see, c, which represents a constant, it's just a number. For example, the c would be 2 in this term. If you have a term that says c times x to the n equals g of x. G of x could also be on the left hand side over here, just like f of x is on the left hand side. Okay, I just didn't write it in front of it, so I'm writing it behind it, but it means the same thing. Then g prime of x, or the derivative of g of x, is just, we're going to take this n, bring it down, and multiply it by any constant, and then we're going to subtract 1 from the power. So it's going to look like n times c times x to the n minus 1. This is the derivative of this, and that's power rule in a nutshell. So, for example, we're going to take the power rule of this x to the third. So f prime of x, this first term, there's an invisible 1, which is like our c. So I'm going to write 1x. Now we're going to take this 3 and do what with it? That's like our n in the general case. 3 is like our n. What do we do with the n? We brought it down. We brought the n down and to be multiplied by the constant. We just bring the n down. So that 3 was here, but we're going to bring it down and multiply it by the constant. So this 3 is this same 3 right here. This c is the same 1 right here. I could have just left the 1 out. Of course, I think you know that already, but I just want to reiterate. And the 3 stays there, but you subtract 1 from it. 3 minus 1. All right, now that's done. All we have to do is simplify, and we'll do that on the next step down here. But I'm gonna write out this whole f of x. We're gonna write out the whole f prime for this f of x before we start simplifying. Okay, so 2, bring that down, times 2. So it's going to be 2 times 2 times x to the 2 minus 1 plus 3, well, we're going to bring 1 down, times 1 times x to the 1 minus 1. X to the first power minus 1. Okay. Plus 5 plus 2 times 5, x to the 2 minus 1. Bring the power 2 down, times 5 times x to the 2 minus 1. Now I'm going to move on to the next line down here, but we're continuing with this. I'll just write it right here. So we're dealing with this term now. That's 10 times x to the first power. So bring down that 1 because it's to the first power, so we bring it down in front. Times it by the constant, or the c, which is 10 in this particular case, times x, and the invisible 1 power is 1 minus 1. Then the derivative of a constant, which is just a number with no variable attached to it, that's called a constant. Excuse me. It can have a variable attached to it, being multiplied by it, but just the constant by itself is just a number by itself. Okay, so the derivative of a constant, any constant, is 0. All right, so this is the derivative of f prime of x. Now I'm going to just clean this up a little bit. All right, this is still this step right here is going back to algebra 2, just cleaning it up. All right, we've done this right here. This step was the calculus. This was the only calculus step in this question. Okay, 3 times 1 is 3x squared, because 3 minus 1 is 2, plus 4x to the first power, plus 4x, plus 3x to the 0 power. Anything to the 0 power is 1, so we don't even need to write it. So this is just 3. Got that? This will be 1 minus 1. To repeat, this will be 1 minus 1, which is 0. X to the 0 power is 1. Anything raised to the 0 power is 1. So you have 1 times 3 is just 3. Plus 10 to times x. 10x is just 10x here. Okay? X to the first power. Because 2 minus 1 is 1. There's an invisible 1 right here. All right? Now, continuing. 10 to the times x to the 0 power. Well, anything to the 0 power is 1, so you don't need to write it. So that's just plus 10. And then plus 0 right here. All right? Now we will combine like terms. Actually, your teacher said you don't need to simplify, so technically, I guess this is the derivative. You can stop right here, and actually later on in calculus, when your derivatives get a little more complicated, it's best not to try and simplify them, because you can make a mistake in your simplification and your teacher may have to mark it wrong even though you did the derivative correctly. However, this derivative is so simple that we're going to combine like terms. So I look through here. I see it x squared. Do I see an x squared here? No. X squared, x squared, x squared. No, that's the only x squared. So I'll write it now. 3x squared. Now I cross that out because I'm done writing it. Now I look, I see a 4x. Do I see any other x's to the first power? Yes, there's a 10x. So right now I'm at 14. 4 plus 10 is 14x. 14x. I cross that out because I'm done with it. I cross that out because I'm done with it. Now I'm just left with constants. 3 plus 10 is 13. All right, and this is the derivative. In another video, I'm going to show the other method, which would be to use product rule on this multiplication of two polynomials, on this function. We also could use product rule to get this same answer, but this is the correct answer. All right.